Hi, I'm Ed Amoroso from Tag Cyber, and I'm here with my friend Kunal Anand, who is the co-founder and CTO of Prevoty. How you doing?
Doing well. Thanks for having me, Ed.
You've been traveling a lot the last couple of weeks, haven't you?
Yep.
Well, let's start with, tell me how things are going at Prevoty. You're the technical lead there. You lead the technology program. You drive the initiatives and strategy. Tell us a little bit about the stuff you're working on.
So it's been a fun 5 years. When we came to market about 5 years ago, everyone looked at us and thought we were crazy for building what the industry now calls RASP, or Runtime Application Self-Protection. And everyone told us initially that we have a firewall. And then they said, well, aside from a firewall, we're doing all this testing and this fixing pre-production using scanners, dynamic scanners or static code analysis tools. And then over the last maybe 2 to 3 years, we've seen a pretty big change of people realizing that, look, the perimeter isn't solving things for us. I think this year we saw a statistic by Synopsys, 98%, there's a 98% re-exploitation rate in web application firewalls.
Really?
Yeah, so I didn't understand properly what that term meant, but here's what it means. Let's say you have a firewall, and your firewall is designed to protect against, let's say, cross-site scripting using definitions or signatures. You can evade those things 98% of the time. So the common approach has been you add another patch, you add another signature.
Right.
Well, 98% of the time you can get around that. So the perimeter isn't working. We're finding that people are scanning and they're finding vulnerabilities in their code base, but they aren't fixing those things. I think the other statistic we heard in the last maybe 1 to 2 years, on average, and this is average, and I actually think it's actually an optimistic number, 150 days to fix one critical vulnerability.
Wow.
So that includes a data exfil. Yeah, so, and we saw a little bit of this happen this year, right? I mean, Equifax is a good example of security hygiene and security processes probably not being followed correctly, where you had a vulnerable library and kind of leading to where we are now with the state of security, where you've got applications that are relying on frameworks and third-party libraries that may include other frameworks and other third-party libraries. So your app may be safe, but what about these other libraries and these other components that make up the things that you're bringing in? So app inventory is scary. And then you combine that with kind of the last piece, which is, and no pun intended, the blind spot in application security is the application. No one really knows what's going on inside the app. So in terms of technology and product, what we're seeing is the last 2 to 3 years, people are looking to runtime to fill those gaps. They understand that the perimeter isn't the right way to go. Looking at virtual patching, especially for trying to solve against cross-site scripting or SQL injection, where you're at the perimeter and you don't have application context is one thing. Moving away from signatures and definitions to an area, I think we'll talk about LangSec.
Right.
Moving away from pattern matching to something different like an evaluation-based technology. And then also having that consistent logging about what's going on inside the application and pushing that telemetry everywhere. So now we're seeing some interesting use cases develop where people are taking this information, and whether it's going back to the development teams and having them reprioritize what they do. So rather than looking at the 15,000 vulnerabilities in the backlog, let's go after the 10 things that are actually being exploited or attacked in production. So you're making things a little bit more efficient. Or if they want to maybe improve tooling with other point products or solutions, they can do that as well. So I think what we're seeing now is people who are adopting the technology. We're seeing some interesting use cases.
That's awesome. So you mentioned LangSec. That's a technology you're very passionate about.
Indeed.
So let's give us a 101, assume nothing, and help us understand how LangSec reduces risk in apps.
Sure. Let's start with how we got to LangSec.
Sure.
Let's go back to pattern matching. So I mentioned pattern matching. A lot of technical people may look at patterns as regular expressions or strings. Let's take the phrase hello. If I wanted to build a pattern for that, I would literally have the words and the characters HELLO. That would be a pattern.
Right.
But I can say hello in lots of different languages. So eventually that pattern, hello, gets cloned and gets modified maybe 100 or 200 different times to accommodate the different languages. The problem is in computing for something like a tautology. So a tautology is a statement of truth, like a 1 = 1. You can express that in an infinite number of ways. The solution set for tautologies is infinite. I can say 1 = 1, A = A, or 1 + 1 = 2. And what we're finding is we've been playing this cat and mouse game of building up patterns and signatures. It doesn't really work. It's not scalable. And in the case of, let's say, a zero-day exploit, you have to wait for the exploit to happen. So someone could be a vendor or could be someone on your team to create a pattern. LangSec changes all of that. So LangSec is short for Language-theoretic Security. And the idea of LangSec is, instead of doing crude pattern matching, let's actually evaluate how something is going to execute. So let's say in the case of hello, what if there was an English interpreter that could understand that, oh, this person is saying hello, that is a greeting. Now we've classified that as a greeting. Or if someone says hola in Spanish, you would also understand that to be a greeting. We've effectively built that capability into our product, where instead of doing pattern matching, we're actually doing evaluation. So when it comes to identifying tautologies, we don't need to build up a set of definitions or signatures like 1 equals 1 or A equals A. We can do the evaluation. We can compare the operands to each other and then understand whether or not those two things are equal.
Should people think about that as a static activity or a dynamic one, like kind of compile time, run time? How would I think about that?
Yeah, so
or is it both?
Well, it's a little bit of both, but the way we apply it is, in a very crude sense, imagine you do this analysis of all the payloads at runtime. And when I say all the payloads, it could be an HTTP variable coming into the application. It could be a database query that leaves the application and goes somewhere else. Imagine you could do the evaluation for those components or for those different pieces of input and understand exactly what it's going to do. Under the hood, it's basically formal language theory where you're constraining input to a language. And you're identifying if that input fits the language, and if it does, great, let's evaluate it. If it doesn't, you can reject it or you can transform it to make it fit the language. In the case of something like a 1 equals 1, you can identify it as a tautology and then express or give the ability to have a rule or an action execute, where if you see a tautology, you may want to drop the query altogether.
Yeah. So that expressiveness changes the nature of what can be detected or not, right?
Right.
Is that the idea?
I think what it does is it reduces the cost of ownership.
Yeah.
And prior to this, I was in a role at the BBC worldwide, and in that role, I was responsible for engineering, operations, and security for digital entertainment and gaming initiatives. So brands like Top Gear, Dancing with the Stars, Sherlock, Doctor Who. And in that role, I was responsible for Eng, Ops, and Sec. And the biggest nightmare I had from a security perspective was dealing with patches, dealing with constant updates to signatures and definitions. And sometimes they'd come from my vendors, sometimes they would come from my operations teams or engineering teams. And I would run into several issues. One was this idea of one pattern fits all, or what, you know what I mean? That idea of one size fits all. It doesn't really work for applications, because I may have an application where a 1 equals 1 is normal versus another application where it's simply not. Or I don't want to allow that behavior to happen. You also run into issues where you're waiting, so there's a gap, there's a period of risk. And I think what this does, at least from a perspective of like investment and cost ownership, LangSec allows you to kind of reduce those costs, because you're not waiting for definitions. You don't need a team to tune.
Very cool.
You know, you've got something that can actually understand the essence of an input.
That's really awesome. You know, another technology or characteristic of technology that is part of your DNA, Prevoty, is autonomy. This idea of things doing something on its own, like not having to have a human intervene. How important is that in runtime application security?
I think it's required, actually. When we came to market years ago, I think we completely underestimated and didn't really understand that. And our very first version of the product was this agent that attached to the application that was calling out to the outside world. And it could be our cloud environment, or it could be a server on-prem. And what we found was the amount of time it took for operations teams and security teams, who by the way, aren't operations experts, no surprise.
Human beings.
Human beings. By the time it took for them to get a virtual machine up and running, or to make a change to whitelist an IP address, or to allow information to go out. And by the way, and you know this too, organizations aren't comfortable with information leaving their application and going anywhere else. Even if it's encrypted, they're not really comfortable with that. What we ended up realizing was we need to take this intelligence that we have, this analysis engine, and we need to put it directly into the applications. So What we did over the last couple of years was we've moved away from external servers and services, and now everything lives within the agent. So we call it the autonomous agent.
Yeah.
And I don't think we're fans of the phrase RASP, unfortunately. It's just the phrase
Well,
that
it's
exists.
autonomous. It's self-protection, right?
That's right.
Essentially.
And it goes back, and it's completely in line with when Julian and I started the company, which is, what if an app could monitor and protect itself? And now, rather than calling out to maybe its parents or friends to figure out, is this safe or not, it can make that decision and take action on its own.
When you do that automation, then I can take a deployment, I can scale like crazy. Then,
Absolutely.
Right? Like instead of having to, is that an important thing that customers ask you about scale?
We're seeing that now. And I think for the last 3 years, people have been talking about DevOps and how security fits in there.
Yeah.
I think it was the joke at RSA of people saying SecDevOps, DevSecOps, or DevOpsSec. Pick whatever variant you want of it.
Right.
But ultimately, security needs to figure out a way how to be part of this movement of people moving faster. You and I have been talked before about Agile. We've talked about how people are moving faster, how development and operations teams are deploying code on their own, maybe without governance from large security teams.
Yeah.
So the idea of having an agent that doesn't require source code to be modified, changed. You don't need to recompile your applications. You can attach the agent to your application, and you can be successful in any environment. Could be, obviously we designed it for production, but it could be in a production environment. That could be a microservice, could be a large monolithic application, could be deployed in the cloud, in a container like a Docker, or a virtual machine like a VMware, or even something like EC2. Want to make sure that it can work in all those different environments.
You know, let me ask you, I always feel sort of conflicted about DevOps because on the one hand, I feel like the way God intended us to develop software was to go slow, I mean, and to get it right, but you can't do that. But on the other hand, doing DevOps right, like SecDevOps, you introduce automation that I think is great. Like, is it sort of have that, like, I don't know, do you think DevOps, the fact that we're going so fast does create some problems, but the compensation is actually pretty good? Am I thinking about that right?
You are, so, and maybe I'm an old timer, but I started my career at NASA.
Yeah.
And that was an amazing place to start a career on the engineering side. And my background, I don't have a degree in engineering. My degree, I like to consider my engineering degree from NASA.
Yeah.
And I learned a few things there. They taught us how to debug, but most importantly, they taught us how to do code review.
Right.
And I think when you look at people moving fast now, that code review component is really gone.
It is.
And now you see people who
I
are
grew
just
up in that environment too, code review and going
important.
slow.
Take your time, build the right things, and make sure that the product, at least what you're trying to do, is what it should be doing. I think the big issue that we have now is people are building things and they expect things to fail. The Facebooks of the world are teaching us to move fast and break things.
Throw it out
Right.
and fix it.
And
Throw
see
it
what
out
happens.
and
This
fix
idea of an MVP, a minimal viable product, what does that actually mean? The reality is you're not really thinking about security anymore. And so for those particular environments, runtime is appropriate. And I think long term, the idea of instead of it being at runtime, what if you could design something into the language? What if you could design something to build secure programming languages? And ultimately, I think 5 to 10 years from now, we may be looking at that. And fortunately, we see some really cool modern languages coming up that I think bake a lot of interesting controls from a security perspective.
That's one of your personal passions, isn't it?
Indeed, yeah. For years, I've been on the side, and it's out in the open, it's publicly available. I've been building a language called Kuala. And the idea of Kuala, and don't laugh at the name, originally started life as a transpiler. What if you could make a language like PHP secure? And it started life basically as almost a meta language where you would build and write PHP code and then transpile it, and it would sit on top of the PHP virtual machine, or basically generate Zen bytecode to run in the PHP VM. And really interesting stuff. And I think it's too primitive and it's not at the right layer. I think if you're going to do this, you actually need to build a secure virtual machine and then allow people to build secure languages. Microsoft had a good thought with the DLR. I think it was about 10 years ago. So Microsoft with .NET had the Common Language Runtime, the CLR. And then they tried to build the DLR, which was a layer of indirection that allowed anybody to build programming languages. So you saw Iron Ruby and Iron Python, crazy names. And John Lamb, the creator of Iron Ruby, had a really cool approach of what if we could harness basically the primitives and all the security sandboxing capabilities in the CLR and went through the DLR. I think rather than having that intermediate layer, you probably need to create a better substrate at the bottom that allows people to build different languages above.
Is there anything people can download on Kuala or read about or
Yeah,
play with?
I have a GitHub repo, and it's full of a lot of unimplemented design notes. Whenever I get the time, I'll tinker with Kuala. But ultimately, I think people today, if they're getting started and they want to play with interesting languages, I would highly recommend the Go programming language.
Right.
Highly opinionated, but I think Rob Pike is doing some interesting work there. And on golang.org.
Good stuff.
And then the other language is Rust. I'd suggest a lot of people take a look at Rust. It's an interesting programming language that tries to remove a lot of errors when it comes to memory management and pointer management. For folks like us who are used to that stuff, it's interesting to see languages being designed that try to remove a lot of those things which seem like they're primitives and seem like things that programmers and engineers should all know, but for whatever reason, modern languages are trying to hide a lot of those things away. So
you always have so much energy and passion for what you do. I have a feeling you enjoy your work every day.
I do. I think
the travel could be less, I'll bet, but everything else is
travel could certainly be less. But I think what's fascinating is we live in a cool time, especially if you're an engineer or a developer. When I was coming up, I would have to park myself at bookstores, and I'd have to go to libraries, and I was lucky if there was a good book about the subject. There wasn't Wikipedia, there wasn't a high-quality version of Google like you have right now. And I think today, if I was an engineer coming up, I would be loving life, because there's a thing called GitHub where there's so much open source code, and if anyone wants to get started on anything at any time, they can go out, jump in, and get started.
It is amazing.
It's just a treasure trove of things. And I'm excited just looking at a few things, the innovation that I'm seeing. So language design is really cool. Really interested in virtual machine design. I think we're making a lot of progress there. And then obviously on the Prevoty side, really excited to see the customers do some great stuff with our products.
Well, good luck with Prevoty. I'm always so happy to talk to you and hear about Prevoty and hear about your great work.
Thank you for having me.
Keep
Really
doing it.
appreciate it. Thank you.
You bet.
Thank you.
And we'll see you next time.